was 1/4 log bx minus 2 log b.
So 1/4 log base b of x.
Yes, and then minus 2 log base b of 5.
Yes.
Minus 10 log base b y.
Minus 10 log base b of y. And they want us to condense.
Yes, it says write as a single logarithm.
Very good. Let me know if I'm not centered, if I'm skewed, or if you can see, right? Please. Perfect question. So when I condense, first of all, I notice that there are two negatives. So two quantities, two factors will go to the denominator, or they come from the denominator. One has positive in front, so only one quantity will be in the numerator. But first I have to address this. They have to disappear before I continue. What does 1/4 mean? Log base b of the power. So that would be the 4th root of x minus. Now power 2. Log base 4 of 5 squared, 25. Minus log base b of y to the 10th. We have to apply the power rule first. We have no choice here. And now it's all set. It's log base. This is base b, right? They're all base b, correct?
Yes, they're all base b.
Perfect. So log base b, and as I said, this quantity has positive, so it comes from the numerator, or it goes to the numerator if you want. And these two have negative in front. They come or they go, if you like, to the denominator. And this is the final form of the condensing. Any questions on that? Any questions? Do we need more condensing?
I have one question, sorry.
Yes, please.
Is it true that whenever you have a number raised to a power in the denominator that you want to just multiply it out, like 5 squared, for example? I wouldn't ever write 5 raised to the, 5 squared y to the 10, I would just put 25. Is that true in every instance?
If I have 5 squared, I would write 25, but if I have 5 raised to 100, I will not change that because it's too big.
Oh, gotcha.
Yeah, but 5 squared, I will write 25. Even 5 cubed, I will write 125, and 5 to the 4th, 625. But if it's something like this, I can't.
Okay.
But normally, yes, I would simplify.
Okay.
Good. Anything else? Anything else? Okay, do you think we need anything else from this section, which is 4.3? Do we need another condensing? Yes or no?
About one more.
Very good. So let's look at 70. On page 501. And that is log x plus log x squared minus 4 minus log 15 minus log x plus 2. If you can see this, it's x plus 2. The same question, we are asked to condense this. It doesn't need really any preparation. There are no numbers in front. I don't have to condense anything, just write the final form. What will be the final form here?
So that's log 15 minus log what?
X plus 2. In parentheses,
Right,
X
thank you.
plus 2. Sorry about that.
It's all right, thank you.
So then how do we write this? Remember, if log has positive in front, the two quantities go to the numerator. And if it has negative in the in front, they come, or they go, if you like, to the denominator. So, however, I look at the expression and I realize that I can simplify a little bit. How can I simplify this? I can't at this stage, but I can factor x squared minus 4. How do I factor x squared minus 4?
X plus 2x minus 2.
Very good. And therefore I can simplify one of the factors from the top with another from the denominator. So now the form is this, and I cannot do anything else to it. So this is it. You will see why we need to know how to condense. The applications are in section 4.4, in the next section. So, are we moving on to 4.4?
All right.
Okay, very good. So, the last two sections of this chapter, one deals with exponential and log equations, and the last one with more applications. We've seen several applications in real life situations, but we're going to look at more. And that will be the end of chapter 4. So section 4.4, exponential and log equations. So we'll start with exponential. And I'm going to just use a couple of examples that are very easy, and then we will look in the book. So let's take a look at, let's say 2 to the x equals 2 to the 4th. This is our first exponential equation that we look at in this class. Two numbers are equal and they have the same base. What do you think has to happen to their exponents for these to be indeed equal? What has to happen here?
They should be equal.
There is no other way. It's the only way. Only if this is 4, 2 to the 4th will equal 2 to the 4th. That's the easiest possible exponential equation. Let's look at the next one. Let's say another example will be 2 to x minus 3 equals 2 to the 4th. That's not really different from the previous one. Two numbers are equal and they have the same base. What has to happen to their exponents?
Must be equal again.
Very good. So then x equals 7. Okay, so here's the next step. I'm going to pick a problem now from your book, let's say number 6 on 514. 3 raised to 2x plus 1 equals 27. Well, the key in the previous problems was the fact that the bases were the same. But I don't see here the same bases. This is a prime number. I cannot do anything to it. But I'm looking at the other side and I'm really hoping to change that into a power of 3. It turns out that I can. This is the same with 3 to the 3rd power. If that's the case, then the equation really becomes 3 to 2x plus 1 equals 3 to the 3rd. And all of a sudden I'm back to the previous easy situation. So the same thing again. What does that mean? It means that 2x plus 1 must equal,
3.
yes. So I subtract 1 from both sides, and I divide by 2. Not too bad. Well, of course, we're going to move on to a slightly more difficult situation. Okay, let's say problem 14, same page. Any questions? Please stop me. Any questions, anyone? In 14, we are given y to 2 minus 5 to 2 minus x. They say that equals 1 over 125. Okay, so pretty similar actually, not too difficult yet, not too different from the previous case. I see that the left-hand side is 5, it's a prime number, there is nothing I can do to this, but again there is something that I can do to that and write it with a base of 5, because it's possible. If I can have both bases the same, I'll show you what happens then and what technique we have to apply in that case. But in this case, I can still present both sides with the same base. So how do I change the left-hand side?
Oh, 1 over 5 to the
Yes, it is indeed, you're correct. So it's 1 over 5 to the third power, or 5 to negative 3. Excellent. So this is 5 to 2 minus x equals 5 to negative 3. Perfect. Back to the same situation in which 2 minus x has to equal negative 3. I subtract 2 from both sides. I divide both sides by negative 1. So I get x equals 5. Now let's move on to the next situation. Let's look at 22. 19. Let's do 19. We can do 22 as well if you look at it and see if you want it. So 19. 8 to x plus 3 equals 16 to x minus 1. Well, in this situation, I see that this is not a prime number, this is not a prime number, and I wonder if I could use the same base to present both. Because if I can use the same base to present both, then I'll be somehow in this kind of situation, which is not too difficult. So the answer is yes, because 8 can be changed into 2 to the third, and of course everything raised to x plus 3. And 16 has to be changed into 2 to the fourth, of course raised to x minus 1. So I was able to present both sides with the same base. Of course it's not done. Now I have to use the power rule. And let me refresh your memory on the power rule. A raised to n power, everything raised to the nth power, I copy the base and multiply the exponents. And this is what I have to do now. I copy the base and I multiply the exponents and I get 3x plus 9. I distribute. I copy the base and I multiply the exponents according to this rule. And I have 4x minus 4. And yes, now I'm back to the previous situation that I was in a few minutes ago with the previous case. Both with the previous, all cases from before. Two numbers are equal, they have the same base, their exponents have to be the same. So I have 3x plus 9 must equal 4x minus 4. This is a linear equation. I move 4x and I move 9. When I move 4x, you can write, I just don't like to write this. unless you want it, that's fine. So negative x. And when I move 9 to the other side, I subtract 9 from both sides. So then this is negative 13. Multiply by negative 1, x equals 13. Any questions on this? Any questions? Well, life would be...
When you asked, you just muted all of us.
I did?
Yeah.
I'm sorry. I just, if you don't mute yourself, then everyone will hear everything you say, or that's what I said. And just unmute yourself when you say something.
Oh, okay.
Yeah, that's the best thing to do.
Okay.
Sometimes you may have some noise in the background, and then everybody will know it, will hear it. Okay. Any questions? Please ask anything. Well, of course, this would be nice if this would always be possible, but it's not. So let's look at situations in which this is not possible. Like, for example, 27. In 27, we have 5 raised to the x power equals 17. Obviously, it's an exponential equation. How do I know? The variable is at the exponent, so, or is the exponent. So it must be an exponential equation. Okay, then in this case, this is a prime number, this is a prime number. There's no way I can present them with the same base, this or any other. This no one can change into a simpler way. This is it. But there is a way of solving for x still. Okay, before we look at this problem, let's take a look at this. How do we solve this equation? I want to connect the concepts. I want you to understand how we think.
For both sides?
Right. How come that I don't cube? Oops. I want to cube both sides. Well,
Then you have x squared equals 4 to the third.
I want to cube both sides. Can I cube both sides and solve the problem? No. Why am I squaring? Because the square root of x and x squared are inverses of each other. Applying this function to both sides eliminates the square root. I'm applying this to this, or I'm applying this to this. So the answer will be x equals 16. And we're done. And we go back and check. Well, the same thing here. I need to apply a mechanism, like I applied here. I applied power 2 to both sides. I need to apply a mechanism to both sides that will eventually allow me to bring x down as a factor, so I can solve. I cannot solve with x up there at the exponent level. But if I apply something to both sides, the same thing, to both sides, I will be able to bring down x. So what will work here?
Natural log.
Indeed. Or the other one that we have in the graphing calculator. Here we squared both sides. In this case we can't. We apply natural log to both sides. And now remember, x goes in front. Natural log 5 equals natural log 17. I just don't want you to get if you want to get off by looking at this. This is just a simple number. Or this. It looks fancy. It has that natural log in front, but it's just a number. So if you plug it in, over here it is, natural log, and if I plug in 5, I get 1.61. But we have to keep it like this because this is exact and this is an approximation. So don't get, how I'm looking for the best word. Don't don't get thrown off by the fact that this 5 has this function in front of it. It's still a number. These two are together. You cannot separate them. Natural log 5, natural log 17. A number, a number. So then how do I solve for x? Well, of course, I'll divide this number by that number. And I'm done. Yes, we can approximate, so we can check the answer. We can do that. So natural log 17, don't forget to close the parenthesis, and divide by natural log 5, don't forget to close the parenthesis, and I get 1.76. So that's approximately 1.76. And I want to check. Remember, the equation was 5 raised to x equals 17. How will I check? I will raise 5 to this number and see if I get 17. But here's how I want to do it. 5 caret, and I'm going to call the previous answer. I want the calculator to include everything, all decimal digits, because if I just use 1.76, I will get close to 17, but I will not get 17. So I press enter, and I get 17. So then, this is indeed the correct answer. So what's with this procedure? Well, this is applying the inverse function to both sides, like we did with this function, with this equation. We applied power 2. We squared both sides to get the answer. Here, we have to apply natural log. Can you apply common log? Yes, as long as you apply to both sides. You get the same answer. It doesn't matter what you apply. But of course, you should apply either log or ln, because you have them in the calculator, so you can determine what you need in order to simplify or check the answer. Not simplify in this case. How do we feel about this problem?